So this will be example number 5 from slide, and this will be the last example for RL circuits. After that we will move to RC circuit. And again, this is a circuit that has both AC and both DC and DC portion also, and we are asked to find out the current through this resistor after switching occurs. Okay, the first portion is always like before, find out time constant. To find out time constant, we have to see what is the equivalent resistance seen from from inductor terminal, and I have to like always make all the independent sources 0. Voltage source, if made 0, turns to be short, and current source becomes open. So equivalent resistance will be 5 plus 5, these two are in series, so R equivalent will be 10, and that gives you the time constant L over R equivalent 0.01 over 10, and that gives you 1 over tau equals to 1000. So transient portion of the current will be some constant A e to the power negative 1000 t. Now we have to find out our steady state solution, how the circuit looks in steady state. Now as there is two portion of voltage source, AC and DC, we will use the method of superposition. That is, we will turn off one and consider what is the current going through 5 for it, and then we will turn on the another and turn the second one off and consider what's the current going through 5 again, and we will simply superpose them and we will find out the total current that's going through 5 ohm resistance. So when you turn off this 4 ampere current source, it becomes open, and for AC portion I'll be saying like this kind of 5.01 in phasor domain will convert to J10, and this is 5 again, and in phasor domain the voltage source will look like this, 100√2 angle of 15 degree. Now we are asked to find out the current through 5, and that will be pretty much easy. I first portion of steady state, I1SS, that means the first portion of steady state, that steady state portion caused by the AC source, that will be 100√2 angle of 15 degree divided by 10 plus J10, and that equals to 10 with an angle of minus 30 degree. So that means I1 steady state in time domain would be 10 sine of omega t 1000 t minus 30 degree. Now for DC, we have to turn off this voltage source, and we have to keep turning on the current source. Sorry, this diagram is wrong. Now remember, in DC steady state, inductor acts like a short circuit, so I'll make the inductor short. There is a 5 ohm resistance here, and this voltage source is turned off, so it will be short. And then there is this 4 ampere current source. Two equal resistance in parallel, so current will be equally divided. So current that goes through 5 in this direction, opposite direction, will be 4 divided by 2, but this is in opposite direction, so I2 steady state will be -2. So total steady state solution will be 10 sine of 1000 t minus 30 degree minus 2. And so if we now make the complete solution, it will be the summation of transient plus steady state. So complete solution will be a e to the power minus 1000 t plus 10 sine 1000 t minus 30 degree minus 2. Now we have to find out initial condition, that means what is the current value at the moment t equals to 0, and for that we need to know what is the current going through the inductor at t equals to 0 and what is the voltage source's value at t equals to 0. So to know the second thing, the current going through the inductor at before t equals to 0, we really go to the circuit at the rate t equals to 0 minus, and then t equals to 0 minus, this is open, so this portion will not affect, there will be just only this portion of circuit. And inductor acts like short circuit in this steady state, so 4, 5, and so as you can see, the current through inductor at the moment t equals to 0 minus will be 4 amps going in this direction. The direction is also important. So as inductor current cannot change abruptly, current through inductor even after switching will be 4 amps. So now let's move into the circuit at the rate t equals to 0 plus. After t equals to 0 plus, there is a voltage source over here. You can see from here there is a voltage source over here, then 5 ohm resistance, then another 5 ohm resistance, inductor, then and a branch having 4 amps. And we want to fully concentrate on what's the current in this branch at the moment of 0 plus. Now we know that the current going through the inductor even after switching will be 4 amp, so that is given. And we also know the voltage source's value. I don't think that's important, but we can know. Anyway, let's apply mesh analysis now. To apply mesh analysis, I'll introduce two mesh current, I1 and I2. So I2 will immediately be negative 4 amps, and as you can see, I1 minus I2 will be 4. So I1 minus 4 equals to, I1 minus 4 equals to 4. So I1 plus 4 equals to 4. So I1 equals to 0. So the current at the moment of 0 equals to 0. This is our initial condition, boundary condition. Now we have to apply this initial condition in our complete solution. So to do that, I will put simply t equals to 0 in our complete solution. That will become a plus 10 into sine negative 30 minus 2, and that has to equal to my value 0. So if we apply and find out, a value will be 7. And so complete solution as a function of time will be 7 e to the power negative 1000 t plus 10 sine of 1000 t minus 30 degree minus 2. This will be the complete solution for the current for t is greater than equal to 0 degree. That's all for RL circuits. We'll move to RC circuits now.